everyone and welcome. Today I'm going to show you how to configure static routes. And what we have in this scenario is um, three routers. We're going to install weak cards on it, serial connections, so that we can connect them together. And I'm just going to copy and paste these connections. As usual, we're going to create a map of what we're looking for here. So let's do that. This router is going to be called Boston. This router here is going to be called Buffalo. And this router here is going to be called Bangor. Okay. Okay. We've been given an IP addressing scheme, IP version 4. So I'm going to follow that scheme. No subnetting necessary in this particular lab. The networks have been assigned already by a network administrator. So in this case, what we're going to do is install serial connections, and as usual, I would recommend choose the one with the little clock on it, serial DCE, because you're gonna have to remember that for when you're performing your configuration. All right, and it's a good practice to click on this little icon here and make a note in here. I'm just gonna make a note here somewhere right there that this is DCE. That's my DCE end. All right, and also I want to make a note of the serial port. This one is serial 00, and this one here is serial 01. Okay. Let me just copy and paste that real quick. Yeah, like that. Yeah, I apologize for the delay here. It takes a little bit of practice to get familiar with the way this packet tracer works. It's not always accurate, as you were able to see, on regards to the position of my my mouse or pointer. I'm gonna set the serial 00 on Buffalo and the serial 01 on Bangor, and let's make a note of that as well. Okay. This is important, as I have told you in previous lessons, that labeling these devices in this way when you are creating your diagram will help you be more accurate when you're performing the actual configuration. Okay, so we're gonna make it like that, and then from here we're going to set up some switches. And what we're trying to do here is we're gonna have a network here, a network there, and another network here. Okay, and each one of these networks are going to have a number of devices connected to them. So we're gonna choose laptop for this purpose. Okay, and we're going to connect these devices utilizing straight through cables from fast Ethernet 00 here to 01 here, and let's make a note of that. Okay, and we're gonna connect from this switch fast Ethernet 02 to fast Ethernet 0 here, and let's make a note of that. All right, we're gonna perform the same function here. We're gonna set up connection from fast Ethernet 00 to 01 to the switch, and then from the switch from fast Ethernet 02 to the network interface card here, and let's just label that real quick. Okay. And we're gonna do the same thing with this LAN from fast Ethernet 00 to 01 using a straight through cable, and from 02 to the NIC. And we're gonna label this accordingly. Okay, let me put a label on here because I want to keep in mind high level what we're trying to do here. We're trying to configure static routes. Okay, every router needs some kind of instruction in order to understand how it's going to manage packets that get to their memory. Okay. The network that we've been given for this area is 172.16.10.0 with a CIDR of 24. The network we've been given for this area over here is 172.16.20.0 with a CIDR of 30. The network we've been given here is 172.16.40.0 with a CIDR of 30 also. And in Buffalo, we've been given network 172.16.30.0 with a CIDR of 24. And for Bangor, we've been given 172.16.50.0 with a CIDR of 24. Okay, let me save this file because I don't want to lose my work as I progress. So I'm gonna call this one configuring static routes. All right. Before you deploy actual equipment, it's a good practice to do the configuration here in a simulator, such as a Packet Tracer. There's other simulators out there that you can look for, but this is the one that is created by Cisco. So if you're dealing with Cisco equipment, you might want to stick to an emulator like this or of higher quality. All right, and then what we're gonna do is we're gonna set up an IP address here of that one, IP address here of that 10. Okay, and this one is gonna be, this IP address here is gonna be that one. Let me do that again real quick. Oh, I don't like my letters to overlap, so that one. If you're having an issue understanding why I'm putting the that one here, you should watch my other videos. because I'm basically saying here that it's the entire address, like 172.16.20.1, with that CIDR right there of 30. You might need to watch my other videos where I explain more of the fundamentals. But by the time you get to this point, you should be able to cut some corners, if you will, because you already have an understanding of the basics. So it gets a little easier as you move forward once you have an understanding of the basics. We're gonna make that one 02. I'm gonna make this one FA01 at that one. Um, and this laptop here at that 30. And we're gonna make this one here and that one. And we're gonna make this one here and that two. And this one is gonna be at that one. And this one is gonna be 8.50. Okay. Let me save my work real quick. So in this case, I would normally come here with a laptop and connect my laptop using a console cable from an RS-232, which is a serial connector, to the console connector here. And as I have shown in other videos, it's an actual RJ45 port in the back of the device that you would use to access the operating system of the router, if you will. So let's just go ahead and do it this way. For the first one, I'm gonna say no, I don't want to continue with the configuration dialog. And this router is a brand spanking new router, so there's no configuration on it. We might need to perform basic router configuration. I'm gonna cut this short and go straight to what we're trying to do. So that you can see what it takes to get a router up and running with a static routing. So in this case, we're not configuring OSPF or RIP or any other routing protocol other than we are manually we're going to manually create routing tables so that these routers will know how to handle packets that come their way based on the source and destination. Okay, so what I'm gonna do is with the Boston router, let me go back to the terminal real quick, and let's set up Boston. Okay, I'm gonna do config T or enable in this case to go from user to privilege, and then config T or configure terminal to go from privilege to global configuration. And then here we're gonna set up the host name, and this one is gonna be Boston. Notice how my prompt has changed. And then from here, I'm going to go straight to configuring the ports. So I'm going to go to the interface FA00, 0/0, and we're going to set a description here. Boston to engineer to LAN 10.0. That's the name of the interface or the port description, interface description. And we're going to set up an IP address here of 192.172.16.10.1 with a subnet mask of 255.255.0. That's the CIDR 24. And we're going to issue a no shutdown that should turn my connector on. I'm going to go to N and copy run star to save my configuration from running to non-volatile random access memory. Now I'm going to go to config T and go into the interface 000. And I'm going to add a description. This is a serial link to the Buffalo router. Okay, and 000. And I'm going to set up an IP address here of 172.16.20.1 with a subnet mask of 255, that 255, that 255, that 252. That's what the 30 over there stands for. Okay, you didn't like that? Oh, see, that's the trick. You know, when you're talking and typing, it's really hard. So I really hope that you guys appreciate all the work that I'm putting in here. So IP address is the command, 172.16.20.1. We're gonna set a clock rate of 56,000. That's, you have to set a clock rate on the DCE end, and we're gonna issue a no shutdown command. Okay, this port is logically on, but it's physically off. We're gonna need to configure the Buffalo router in order to have these connections be talking to each other. So we're gonna copy the running configuration to the startup configuration. Okay. Right. So from here, let's go to the Buffalo, and let's go to the command line here, and let's do enable config t hostname Buffalo. Okay. And from here, we're gonna go to the interface 001, interface 001, and we're gonna add a description here. This is the serial link to Boston router. Okay. All right. From here, let's set up an IP address. IP address 172.16.20.2 with 255.252, and we're gonna issue the no shutdown. I want you to notice in this area, right, that once I've done the configuration here and then here, and I issue the no shutdown command here, these dots are going to become green, indicating that they can actually see each other now because I configured their an IP address within the same scheme. All right, and I'm going to go to end and copy run start. All right, now I should go back here and configure my LAN as well. So let's go to config t interface FA00, and I'm going to add a description here. This is LAN link to network 30.0, and we're going to issue an IP address here of 172.16.30.1. We need a subnet mask 255.255.255.0, and we're going to issue the no shutdown command. Okay, notice how this link went on also. All right, and now we're going to configure the serial 00 here. If I'm not mistaken, I think I forgot that this serial here is also a DCE. Okay. So we're gonna set a clock rate on there. Okay. So here in Buffalo, we're gonna go to interface 000. We're gonna add a description, serial link to Bangor router 000. Okay. And we're gonna set up an IP address of 172.16.40.1 with a subnet mask of 255.255.252. And for some reason I didn't take that, so let's take a quick look. Okay, I know what the reason is. I type a comma here instead of a dot, and you have to remember this is a dotted notation. And we're gonna set up a clock rate of 5600 or 56,000, and I'm gonna issue the no shutdown command. Okay, again, this is administratively on but physically off until we configure the other end. So let me type in here end and copy run start to save my configuration. All right, And then let me close that and go to the Bangor router. I'm going to do the same thing, configure the host name. So in the global configuration, you do host or host name. And here we're going to call this one Bangor. Notice how the prompt changes. And from here, we're going to issue command of to allow us to access interface 001 0/1, and we're going to add a description serial link to Buffalo. Okay, and we're going to issue an IP address of 172.16.40.2 with a subnet mask of 255.255.255.252. And we're going to issue the no shutdown command that brings that connection on. Okay, and then from here, let's go to interface FA00, and we're going to issue a description. This is link to LAN 50.0. Okay, and we're going to issue an IP address of 172.16.50.1. Of course, we need a subnet mask as well. 255.255.255.0. That's what the 24 here stands for. And we're going to issue the no shutdown command that turns that router on that interface. And we're going to copy run start. All right. So, okay, at this point, this is after you've done all your basic router configuration, configure your interfaces. Now you're ready to configure these devices, the routers, with a routing protocol. In this case, what I'm trying to do is show you how to set up a static route. We're basically statically configuring these devices to remember which ports or which direction each network is. So when you configure a routing protocol like OSPF, those protocols are automatic, right? They can acknowledge and remember automatically. If something changes in the network, it's gonna remember. It's gonna make adjustments to its routing table. All right. So in this case, what we're gonna do is we're going to access the command line on the Boston router, and let's go to config T. That raises our ability to make adjustments to this device, and we're gonna do IP route. IP route is the command that configures a static route. And you can configure a static route, basically telling this router if you have any packets, okay, that belong to this network over here. So IP route, sorry, not IP router, but IP route 172.16.40.0 with a subnet mask of 255.255.252. If you have any packets that comes to you that are destined to this network, I want you to send them out, okay, through the following IP address. And what we use is the next hop's IP address. So in this case, this one right here is the next hop's IP address. All right, so we're going to type in here 172.16.20.2 and press enter. All right, it didn't give us any errors, so that means it took my command, and that's exactly what you're looking for. No announcements is a good thing. No announcements means that the command that you entered went right in. Okay. We are also going to tell this router, okay, IP route, if you have any packets that belong to that 50 network, so this network here, we want you to send them out the following port. Okay, IP route, if you have any packets that are destined to 122.16.50.0 with a subnet mask of 255.255.0, we want you to send it through 172.16.20.2. So I want you to make a note that what we're doing is we're stealing this router. If you have packets that belong either here or here, we want you to forward them to the next hop. Okay, forward them to the next hop, and then that router is going to have to figure out what to do with that. All right, so we're going to end here, copy run start. Okay, and I am also going to tell this router that IP route, that if you have any packets that belong to the 172.16.30 network, that's 0, with a subnet mask of 255.255.255, that's 0. I want you to forward them through 172.16.20.2. Okay, and also 172, if you have any packets that belong to 172.16, let me see, I think I got every network actually here, so I don't need to do any more here. I got the 50, 40, and 30, and one way in which we can confirm is by typing the show IP route. All right, we've entered these routes into the memory of this device, and by typing copy run star, I've saved the running configuration to the startup configuration. So I want you to notice how the S here, there is a map over here of, or a legend, if you will, of what these letters on the left mean. So the S here means that was a statically configured route. Okay. The C over here means that it's directly connected, as it shows here. The S means static, and the C means connected. So static configurations are configurations that we enter manually into this device. And this one looks like a pretty decent, clean routing table. All right, so let me just copy run start here. And now I'm gonna go to Buffalo. And from here, let's do config t. And we're also going to configure an IP route here. This is a static route. And what we're going to tell this router is that if you have any packets that belong to 172.16.10.0 with a subnet mask of 255.255.255.0, we want you to use this serial port. So if I'm configuring this device, I can either use the next hop's IP address, or the exiting port's interface number, or name designation. So in this case, it's 01. We're going to use 01. If I was to use the IP address, I would have said 172.16.20.1 instead of the serial 001 here, and it's going to pretty much do the same thing. It's going to send the information out through that port. Okay, we're also going to tell this router if you have any information that belongs to the 50 network, one IP route 172.16.50.0 with a subnet mask of 255.255.0. We want you to send that out 000. That's that connector right there. So if you have any packets for this network, send them out that direction. Okay. And let me copy run start to save all the changes that I made. Now let me go to the Vanguard router, and then from here we're going to go to config t, and what we're going to do here is I want to show you how to configure a static route that we define as a default route, meaning that if we're going to tell this router, check it out, we're going to do IP route. If you have any IP address that's 0.0.0.0, that's what that means. If you have any IP address with any subnet mask that's 0.0, 0.0. We want you to send it through serial 01. Okay, this is what we call a default route. A default route is going to grab any packet, regardless of the IP address or subnet mask, and forward it that direction. If it doesn't have in its table a route for the specific IP address and subnet mask that is defined for source and destination, then it's gonna send everything out into that port that we're configuring with that's 0.0.0.0 IP address 0.0.0 with a subnet mask of 0.0.0.0. So everything is gonna go out through serial 01. Let me in here, copy run start. There you go. Okay, now from here, let me set up my computers in here. And this IP address is 172.16.50.50. And the subnet mask is 255.255.0. And the default gateway here is going to be the address that we assigned to this connector here. The FA00 is 172.16.50.1. Okay, we're going to do the same thing here. Let's configure this laptop with an IP address of 172.16.30.30. Subnet mask 255.255.255.0 and a default gateway of 172.16.30.1. And we're gonna set this other device over here with an IP address of 172.16.10.10, subnet mask of 255.255.0, and a default gateway of 172.16.10.1. Okay, everything should work at this point because we've done configuring all the IP interfaces and we've configured the routers with default IP addresses or default routes rather. So let's try this out. Let's do ipconfig /all. That tells me what my default gateway is. Let's ping 172.16.50.1 and it's responding. Okay, you're getting a reply from that IP address. We're going to ping 172.16.40.2 and we're gonna respond. So far so good. We've been able to go from this computer to this port and then to this port over here. Now we're gonna test this connection over here. So we're gonna do is ping 172.16.40.1. Okay, and it's thinking about it. It's thinking about it. All right. It's still thinking about it. Okay. So we might need to double check why this device is not working. So let's do a show run, show IP interface prefix instead. Let's just double check our IP addresses. This is 000, should be 172. Okay, it looks like it's up. We might need to check our subnet mask configuration. So let's do a show run instead. Okay. No, it looks right. It looks absolutely right. Okay. So let's look at this configuration as well. And that looks correct as well. So let's try this one more time. Ping 172.16.40.2 and that's responding. So from here we're going to ping 172.16.40.1, and that's not responding. So let's try to ping from here. Okay, ping 172.16.40.2. Yeah, and it's responding from there. So let's ping from here to 172.16.30.1, and let's ping to 172.16.20.1, and let's ping to 172.16 that 10.1, and let's ping into there. Interesting. Okay, and so let's go ahead and ping from here 172.16 that 10.10, and that one is okay. That one seems to be pinging as well. So we have an issue between this computer and that router, and we're gonna diagnose it in a minute. Let me check connectivity going the other direction just to make sure that that we're on the same page. So let's do an ipconfig /all. I'm gonna ping 172.16.10.1 from here, and that's responding. We're going to ping 172.16.20.1, and that's responding also. We're going to ping to 172.16.20.2, and that's responding, so that looks good. And we are going to ping 172.16.30.1, and that's responding. And we're going to ping 172.16.40.1. Okay. Now let's try one ping 172.16.40.2, and let's ping into that. And we're going to ping to 172.16.50.50. Okay, so for some reason this is not working. So let's look at the configuration. Let's see what we did wrong here. That's right. 172.16.50.50, 16.50.1. That looks right. Okay. It looks like our let's look at our IP route. It looks like it's configured accordingly. The default. Let's see. No, that looks correct. We should be able to ping the other direction. So let's try it one more time. Let's see if it has resolved. Sometimes these configurations take a while to resolve internally. So let's do ipconfig here. We're gonna ping 172.16.50.1, and that's responding. We're going to ping 172.16.40.1, and that's not working. All right. So in this case, we might need to do further configuration here. So this is what I'm gonna do. Let me see. I'm going to tell this router, okay, we're gonna configure instead with the serial. We're gonna do an IP address, IP route 0.0.0.0 with a subnet mask of 0.0.0.0. Send it to 172.16.40.1. Okay, and we're gonna copy run start. All right, let me do a show run real quick here just to make sure that I didn't miss anything. All right, so it looks okay. So let's try this again. I'm gonna copy run start. Okay, let's try to ping. Uh, 172.16.40.1. still not recognizing the connection going the other direction. Okay, so let's try further connectivity testing. We're gonna ping 172.16.40.1. Oh, that's not working. Okay, we're gonna ping 172.16.40.2. And it works to there. So obviously this router needs to be configured further. Sometimes the static route is not gonna do what it's supposed to do. So let's configure this device manually so that we're gonna do an IP route here, and we're gonna tell this router, if you have any packets that belong to 172.16.30.0 with a subnet mask of 255.255.0, send it through serial 01. Okay, if you have any packets that belong to 172.16.20.0 with a subnet mask of 255.255.252, share it through serial 01. If you have any packets that belong to 172.16.10.0 with a subnet mask of 255.255.255.0, share it through serial 01. Okay, I might have to fix this over here. Let me see. Yeah, I need to fix this because that's not gonna be acceptable. So the way to remove a static route is to type the no command before the command. So no IP route 172.16.20.0 552 serial 01. So it's easy to make mistakes, so it's no big deal. You just gotta double check yourself as you're working with this thing. So we're gonna reconfigure that IP route 172.16.20. Let me see that 20.0. That's an mask 255.255.0. Send it through 000. There you go. Oh, it didn't like that for some reason, so let's look at that a little closer. 255. Oh, I missed a 255 there, so let's 255. That's 0. Is that a 20? It's actually a 30. So it's 252. That's serial 0. Okay. We're gonna do a copy run star, and I'm gonna do show IP route to make sure that we got the right configuration. So it looks like we got the 10 to 30, and we got ourselves a static route just in case. So so that it can route information that direction based on the IP addresses in the tables. I should be able to ping from here now 172.16.50.1. That's replying. So now I'm going to ping 172.16.40.2, and that's replying. And I'm going to ping 172.16.40.1. And it's trying to ping. Trying to ping it still. And for some reason it's not working. So this is where the real troubleshooting really begins to take place. Okay. Let's do ping. Let's do this one more time real quick, because I don't want to give up just like that. Alright, I'm almost done, so bear with me here. I'm gonna send packets from here to here. I'm gonna send packets from here to here. And I'm gonna send packets from here to here. from here to here. I'm going to make this quick, and I'm gonna play. Let's see what happens. This is why this is important. That now it looks like the packets are actually traveling. So for some reason that computer is not representing that these packets are traveling the right direction. So let's try one more time. Yeah, it looks like it's traveling from that router to that router. And if I want to send packets from here to here, okay, that's working. So from here to here, let's try that. And as you can see, we can follow the packets. All right. Okay. It looks like we might still need to do some more configuring on this router. So let's do enable in Buffalo. I determined that because the packets are not traveling the other direction. They're coming from Buffalo. They're coming from Bangor, but they're not going back to uh, from Buffalo to Bangor. So let's do a short run over here. Okay. Let's double check our IP addresses. Looks like .10, .20, .40, .252, 30. Okay, so that looks correct. All right, so let's do a show IP route. And it looks like we don't have the 50 network in this routing table, and that's why it's not working. So we have to add that to our routing table here in Buffalo. So let's do that, config T. I'm glad that this happened because you're gonna have to be doing a lot of troubleshooting when you're working with these devices. It's rarely that it's gonna work the first time. The real learning begins when you're run into this situation where, okay, this is not working. What do I need to do? I need to look at the numbers, look at the routing table, look at the IP addresses, the subnet mask, passwords, or any other configuration that you may need to be looking into in order to troubleshoot these devices. The real networking happens at the troubleshooting level. So we're gonna do IP route 172.16.50.0. That's on the mask 55.0, and we're gonna use 000 for that. All right. So these packets now, if I do an actual simulation, they should be able to travel from here to here. Let me speed this up a little bit so that there you go. There you go. If you want to add some sound to this, you can go here to options, preferences, play sound. And I'm not sure if you can hear that, but that should be music to your ears. This network is communicating using static routes. Okay, so let me say my work. I hope that this is helpful to you. You know, this is one of the basic skills that you need for your CCNA exam and for your Cisco exam as well. I would also recommend that you take the time, if you build this network, to do basic router configuration. So configure your VTY, your line console, your auxiliary, set up passwords, encrypt your passwords, set up a banner of the day, and then test for connectivity using a telnet connection. All right, this is just basic routing skills, and I hope that this is very helpful to you. Click like and subscribe. Thank you.